Hello, students. Welcome to the first lecture. So, chapter one, it is about the physical world. So, you know what is physics? So, think about that. So, normally humans are very curious about the things that is going around them, especially the stars in the night sky, then the celestial bodies, how it is moving around the sun, and the change in seasons at different time, how tides occur, and the eclipse, solar eclipse, lunar eclipse, how it occurs. So, plenty of curiosities, things are happening around him. And the exact definition for physics is it's a study of nature and its natural phenomena. So, as you know, there is a lot of natural phenomena are happening. So, how the volcanic eruption takes place, how the rainbow occurs, a lot of things are there. So, from the childhood onwards, people are curious about these things. They want to know the things, how it happens, how these stuffs work. So, here comes the evolution of the science and the technology by knowing the unknown. So, as we know, science, it means to know. It comes from the Latin word which is called as scientia. And in Sanskrit, it is mentioned as Vinyan. In Tamil, it is mentioned as Ariviel. And in Arabic, it is mentioned as Ilm. So, all these mentioning the same meaning, that is knowledge. Okay. And throughout the history, there are plenty of contributors to science, especially the Egyptians, Indians, Chinese, Greece people, Mesopotamians, etc. etc. So from the 16th century onwards, there is a lot of contribution towards science. So with this introduction, let's move on to the basic thing in physics. There is nothing but measurements and units. So as you know, physics describes the laws of nature, how the gravitation work, and then a lot of other things also. So in olden days, humans used their footsteps and their hand size to measure the certain distance. So as humans evolved, they become civilized and they have a different measuring things. So here we are going to discuss about the different types of unit system they followed to measure the different physical quantity. Okay. So, for example, length is a physical quantity, then mass is a physical quantity, and time is a physical quantity. So, they want to have a standard rather than having different forms of units that is followed by different peoples around the world. They want to have a standard. Okay, so here comes some of the things that is followed by the ancient people. So you can see using the hands they are using to measure. In Tamil it is mentioned John. This is Muram, and this is foot. There is nothing but the mentioned as Adi. So for time they use a, long stick and the help of the shadow that is falling around, and they will mention the time with the help of the shadow position. And for measuring the mass, they use the millets, grains, especially the corn uh, and other type of grains. Some amount of grain they use, and the multiples of them is considered to be the mass. And in olden days, there are different systems are there. There is one is CGS system, then FPS system, and another one is MKS system. What does this mean? So this means CGS means centimeter. This is to mention the length, and gram to mention the mass, and second to mention the time. This is FPS system is foot pound second. So it was normally followed in the European countries, especially in Britain. British people use this foot pound second. Hope you have heard about this pound in this year also. And MKA system is nothing but meter, kilogram, second. So nearly in this place they reached the um, measurement system what we are following now, and all the peoples comes to a conclusion, especially the scientists, they come to a conclusion that we have to follow a common units, and that is mentioned as SI unit, or you can say it as System D International. So for this, the scientists had a conference. The scientists of the world, they have had a conference. I think it's in the year 1941. And they come to a conclusion to follow a certain unit. Okay, so here you can see some the basic physical quantity. These are the basic physical quantities. One is mass, length, time, current, temperature, amount of substance, luminous intensity. So these are the seven fundamental quantity or the seven basic quantity. They are mentioned with the help of a symbol M for mass, L for length, T for time, I for current, and then T for temperature, and then N for amount of substance, this IV for luminous intensity. These are the units here. So kilogram, meter, second. So it is similar to the MK system. And then for current, it is ampere, A, and then Kelvin, K, for temperature, and amount of substance it is mentioned as mole, and the last one is luminous intensity, it is mentioned as candela, CD. So these are the physical quantities. These are called as the fundamental physical quantities. So two more physical quantities are there. One is radian and steradian. So this is to mention the angle. So steradian is to mention the solid angle. So for the two-dimensional angle, you can use the radian. ds, and this is r. You have ds by r, theta is equal to. And for solid angle, you should have a three-dimensional object like a cone or something. Inside that, if you take an angle, that itself in the form of a three-dimensional, angle, and that is called a solid angle. It is given by Es by r square. So these are the two supplementary quantity, physical quantity. And physical quantities which are derived from the fundamental physical quantities, they are called as derived quantities. So you can see here. Now, the fundamental physical quantities can be mentioned using alphabetical letters as mentioned here. M for mass, L for length, and T for time, current A, and temperature K. This is mole inverse, and then luminous intensity is mentioned as J. These letters, alphabetical representation of letters, this is especially used in the to mention the dimensional formula. Okay, so M for mass, L for length, and T for time. So these are mostly used dimensions, and based on the physical quantity, the other basic physical quantities also involved. So here you can see some. These are the derived quantities. So area, it's length into breadth. So length and breadth both are mentioned in length. So it is L square, and volume, it is area into height, it is L cube, and density, it is mass by volume. So we have to write M for mass, and it is divided by L cube, so that you will get ml raised to minus 3. And here you have velocity, displacement by time. Displacement is mentioned as L, and time is mentioned as T, L by T. So you can write as L T raised to minus 1. And acceleration, it is of course velocity by time. Already you know the dimensional formula for velocity. So Lt raised to minus 1. So Lt raised to minus 1 divided by T. So if you take this to the numerator, it becomes Lt raised to minus 2. And for momentum, mass into velocity. So mass, you know, m, it is mentioned as m. And velocity, already you know, L by T. So Lt raised to minus 1. So that is what mentioned here. And for force, it is mass into acceleration. So acceleration, already you know. So mlt raised to minus 2. For work, it is force into displacement. So for force, you know, it is mlt raised to minus 2. So into distance, force, it is ml t raised to minus 2 multiplied by distance. So you have it is multiplied by L. So here I forgot to mention that. So m in between you have L square and t raised to minus 2. So now it is perfect. Okay. So for work, it is power, it is work by time. So work, it is ml square t raised to minus 2 divided by t here. So if you take to the numerator, it will becomes, so here also I have, since I didn't mention that, so I will get like this. Okay, so t is taken above, so I will have ml square t raised to minus 1. Okay, so these are the derived units, so you should be careful while calculating. If you miss anything, you will miss the formulas. So okay, so here energy is equal to work. It is exactly equal to work. So for work, already we have found it is, yes, L square t raised to minus 2. So similarly, a lot of other physical quantities also there. So you can have a try in the websites. There are a lot of things are there. Okay, so some of the things we can mention here also. If you see, for angular momentum, it is linear momentum into distance. So for linear momentum, so that is momentum, what is mentioned here, m L t raised to minus 1. Okay, so ml t raised to minus 1 into distance. So it becomes ml square t raised to minus 1. Okay, so you can have some workout by knowing the different derived physical quantities and all. Okay, fine. So in the measurements and units, another thing you should know is how to express the powers of 10. So what prefix you can add? So for example, here if it is 10 power 18, 10 power 18, it is mentioned as exa. If it is 10 power 15, then it is mentioned as peta. 10 power 12, it is terra. So okay, so that is notation is mentioned here. So quintillion, quadrillion, trillion, billion, etc. So it has a name: thousand, hundred, ten, one, etc. So the same for the same you have a prefix. So for 10 power 12 it is tera, 10 power 9 it is giga, and this 10 power 6 it is mega, and kilo, hecto, deca. So normally we use this mega, gigahertz, tera, etc. So you know that to have this memory and all, normally you have used these megabyte, gigabyte, and terabyte, etc. So you're familiar with that. So other things also you should know. Okay. So in the bottom line is below zero. We have 10 power minus 1, it is mentioned as deci, minus 2, it is mentioned as milli, and 10 power minus 6, it is micro, minus 9, it is nano. So this region is especially good for the nanotechnology, and the materials which is in between 1 to 100 nanometer are called as nanomaterials. Okay, so a lot of technologies are developed there. And then this is pico, femto, atto. So for a capacitor, if you want to mention the capacitor value, it is mentioned in terms of picofarad. Okay, so these are the prefixes for the powers of 10. So it start from the macroscopic world to the microscopic world. So these the things which you are studying with the help of your naked eye, what you are seeing. So that comes under classical physics, and which is in the lower dimension, that is mentioned as quantum physics. So classical physics explained about the motion of the object that you can see. It's a movement of a ball or a car or whatever it be. But when you move into the microscopic world, that is in the atomic dimension and all, you couldn't predict that how a particle behave, how it moves. Okay, so it will be having a strange behavior. So there comes the quantum physics. Okay, that's all for this lecture. Let me see you in the next lecture. Thank you, students.